Hello everyone, I just reached the rank of Grandmaster 2 on Marvel Rivals, and welcome to my mini lecture on the continuity equation. So you just did your FET, and you had the pipe, and you were able to do different pipes and see how the shape of your pipe or the size of your pipe affected the speed of your water. So you should have figured out that if you increase the cross-sectional area of your pipe, that makes the velocity of your fluid go down. So a big area, that means small velocity, or smaller velocity. And if you decrease the area of your pipe, then that makes your water go faster. So you increase the velocity. So that is the big idea from the FET. If you figure that out, you're on the right track, you're doing great. And now we want to be more specific on the relationship between the area and the velocity. And we have this equation, they call it the continuity equation. It tells you the relationship between the area and velocity. And pretty much what it says is that the flow rate of your fluid, so flow rate is constant, so it doesn't change. So flow rate is how much volume of fluid passes through some cross-sectional area every second. And the letter for flow rate is going to be Q, because little f is frequency and big F is something like fluorine. So Q, flow rate. So that says volume of fluid that passing through area every second. You might also see it as flux, and its units are meters. Since we're using volume, it's going to be cubic meters per second. And to find the flow rate, you just take the cross-sectional area multiplied by velocity. So A is cross-section area. And its units are, area is just meters squared. And then this V is the velocity. And its units are meters per second. So the area times the velocity of the fluid is the flow rate. And the flow rate along your pipe is going to be constant. So we can rewrite the equation to be Q1 equals Q2, or Q1 and Q2 are different points in your pipe. So we have flow rate here, Q1, and flow rate here of Q2, and they're going to be equal to each other because the flow rate is always constant. And then we can expand the equation. So instead of putting Q1 and Q2, we're going to do A1 V1 equals A2 V2. So whatever area this is, so we can call that area A1, and whatever velocity that is, we call it V1. That's equal to whatever area of the pipe there, so A2, and whatever velocity V2. So this is your equation, and it's called the continuity equation. It's on your formula chart. You don't need to memorize it, but you do need to know how to use it. So we're going to use this equation to find the velocity of your fluid. And we'll use this a lot in next class when we're solving our systems of equations. So next class, whenever we do Bernoulli's principle, they won't give you the velocity of a pipe. So you're going to have to use this equation to solve for a velocity of pipe, and then you can solve the system equations and then get your answer. The big idea is the area and the velocity of your fluid are inversely related. If you just get that today, you are on the right track.